Hello, everybody. You're very welcome to this new brand story. I'm Sean Martin, and we're going to have a good old chat about AI security, which is a very broad topic. So we're going to narrow it down and take it into one specific aisle. See what I did there, Ondrej? One specific aisle of protections. And I'm thrilled to have Ondrej Vlcek from Aisle Security on. Ondrej, how are you?
I'm doing well. How are you?
Very good, thanks. And it's all about outsmarting the adversaries. There's no question they've been taking advantage of new technologies to enhance their own businesses, and it's time for security folks and defenders and researchers and whatnot to do the same. So before we get into all the good things that Aisle does, maybe a little background on who you are, what you've been up to, and what led you to Aisle.
Sure. My name is Ondrej. I've been in cybersecurity for more than 30 years, actually. I started as a developer in the 90s, kernel mode developer. I was doing device drivers for Windows 95 in the year 1995 for a small, tiny antivirus company called Avast. I joined that company when we were like 6 or 7 people. Was lucky enough to join a great team that had a global ambition, and basically stayed in that same company for more than 25 years. Grew from individual developer role into CTO, COO, and eventually CEO. Took the company public, and then in the latest stage sold it to our long-term rival, NortonLifeLock, in 2022. So that's kind of 25-year journey from an intern or from a student developer into CEO of a public company. But then I stayed for a couple of years and was kind of thinking about what to do next. I saw this incredible transformation that's happening in the space because of AI. Obviously, AI in cybersecurity is not a new concept. Most cybersecurity companies have been using some sort of machine learning or AI methods for at least a decade. But with the inception of generative AI and AI used for coding and for reasoning and other these things that we now take for granted, but they didn't really exist 3-4 years ago, it became obvious that the space is going to change completely. And so in 2024, I left Gen Digital, which was the name of the combined company, to co-found Aisle with my 2 partners. And Aisle from the beginning sort of set out this purpose or this objective of basically figuring out how to do vulnerability management, how to rethink it for the AI era. So on one hand, we saw how companies or CISOs are basically drowning in the sea of vulnerabilities. So they have hundreds of thousands, if not millions, of items in their backlogs, and they have no practical means of solving these backlogged vulnerabilities. At the same time, the speed at which the bad guys are able to exploit those vulnerabilities is increasing, perhaps also due to automation or AI-based methods. And so we saw this new thing called agentic AI, which was actually able to somehow automate some more complex tasks, such as vulnerability remediation. And so that's what we decided to invest in and to build a product around. So that's how we got started. I should also say that my two partners, one of them has been sort of thinking about this problem for at least 5 years. Her name is Jaya Bellu. She's a 3-time public company CISO. Before I met her at Avast, she was my CISO at Avast. But before that, she was the CISO of a incumbent Dutch telco company, which actually got breached because of a 0-day vulnerability. And after Avast, she also went to another kind of vulnerability research company, Rapid7. So a really like a wealth of knowledge about the space. And the second partner is a guy called Stanford, who has really no background in cybersecurity, but a strong background in AI. He brings this expertise, this depth in AI as an ex-Anthropic engineer and ex-DeepMind engineer. He was actually one of the early employees at Anthropic and helped build Claude version 1. So really relevant experience. And so the company was founded late 2024. For most of 2025, we were just building the product, doing some prototyping, but also helping open source, because open source today is an amazing, not just obviously important as part of critical infrastructure, but also very important in terms of like training data and ability to basically use AI to get better and to fine tune and to post train based on the publicly available data sets that come with open source. So we did a lot of that, and as almost like a byproduct, we had hundreds of vulnerability disclosures, findings that we somehow responsibly gave to the maintainers, and that hopefully made the world slightly safer place. But then late 2025, so about 7-8 months ago, we basically started commercializing the product and have been selling the commercial version since then.
So give me an overview of a lot of background there, which is fantastic, and we have a long parallel journey that we can talk about after we're done recording about all the work we did in the early days of antivirus. Oh. And so I want to pull on that a little bit, because there's so much abstraction, and almost everything is automated. That, I mean, you're working down on the kernel level. Well, you actually could really see and tell what was happening, right? It was either a byte was on or a byte was off. And depending on where it was in the code, that's what it determined how it was going to function. With so much abstraction, and even in the coding world, with APIs and services, and now with vibe coding and everything, how does what you do with ISLE kind of help bring back the realities of where we probably should and could be with coding and addressing vulnerabilities?
Yeah, totally. The thing is that for many years, developers have been using, let's say, static code analysis tools like linkers, but also some specialized commercial tools that were able to discover some coding errors or some weaknesses in code, especially of certain types, such as memory corruption or kind of buffer overrun type of things. But the reality is that most of these tools were more like, let's say, minor improvements over to the entire process. So very often bugs were basically imported or implemented by developers, and they were hard to find because despite code reviews and other SDLC principles, the experience is that we live in a world where software stacks are riddled with security vulnerabilities. And so this whole idea of basically using AI or kind of new generation AI that can reason about code, that can not only find patterns that somehow exhibit bad behavior, but can actually somehow try to figure out what the original intent of the developer was and how that compares with the actual implementation, and how, if putting on the attacker hat, like how a potential attacker could somehow exploit or abuse this piece of code is a completely new concept that a year ago or 2 years ago when we started was more of a wishful thinking, if you will, but fast forward to today is a practice that actually seems to be working amazingly well. And we have seen that, for example, with Mythos, like this April, when Anthropic announced Mythos and its ability to find novel vulnerabilities in code, the world was shocked and shaken, I would say. But this is something that we have seen at least 12 months before that, just because even pre-Mythos models were actually very much able to do things like that as well. And so, that was the foundation of the product that we have built. So the ability to find hard to find bugs of various classes, including business logic flaws and timing errors and race conditions, etc., then triage them. That is, take into account all sorts of contextual knowledge that is relevant, not just from the repo, but also from the deployment model, etc. And ultimately, last but not least, also fix those bugs. That is, propose code patches test those code patches, make sure that not only that they solve the problem, but they also don't break anything else, etc., etc. Basically, close the whole loop and turn it into a program that can be operationalized across enterprises in record time.
Yeah, so no question, we've been able to scale the finding. I think it's always been a race of who can find that 0 day, or who can find the thing that does have a patch but isn't patched yet. There's a patch available but hasn't been applied, and we relied on things like SIM for searching for low and slow attacks, right, where they get in and start to move around, and then eventually they exfiltrate or do some other action. The response has to scale now as well, and so the taking advantage of that vulnerability is scaling, and we need to be able to respond to that. So you talked about triaging and fixing and applying the patch. Tell me a little bit more about that and how you proceed with that.
Yeah, so I think it's important to look at two different things sort of separately. One is first-party code, that is your code, your bugs, and your things that you can fix in. Like, no one will do that for you. And then there is obviously the supply chain or third-party code, most typically open source code. There's estimates that a typical enterprise app probably contains 10% first-party original code and 90% open source code or dependency code. And so obviously, the biggest risk exposure is on the latter. So the biggest focus typically is on the supply chain when it comes to code security. It's also for the attacker, basically it's a level ground because they also have access to the same source code. They can also use the AI models to find vulnerabilities in that and to generate exploits, etc., etc. So just from the economics perspective, it also makes sense for the bad guys to focus on the supply chain rather than on your original code, unless you are one of the kind of top 10 largest companies in the world, where it might be slightly different. But so, and we do this kind of whole loop for both the first-party code and third-party code. So for first-party code, that would typically take shape of, what you would expect, that is being able to take into account all the potential documentation that comes with the code, all the architectural diagrams, etc., and somehow generate a code fix that not only fixes the actual problem, but is very much aligned with the coding style, with the standards, with whatever is documented as part of the threat model, etc., and somehow make it look really almost like indistinguishable from if a human maintainer, a human programmer developed that same code patch, and then test it in an automated way. For third-party code, I think it's slightly more complex in that, for one, you are probably not going to generate patches for those third-party libraries yourself. You are relying on the third party to somehow supply that. There's a lot of independent initiatives today coming from the Linux Foundation and from the likes of Red Hat, etc. These companies are now investing in expediting or accelerating the generation of the code patches, which is great. But probably the more nuanced thing here is that in order to do all of this, you need good reachability and exploitability analysis, because the reality is that very typically you have a lot of dependency modules. You might have thousands, in fact, in your code base, kind of as part of the transitive dependencies that are brought into your project. But only a small sliver, or really a very tiny subset of that code is actually called from your own code base. Meaning that reachability analysis is absolutely critical, because you don't want to lose any cycles on patching a vulnerability that's actually never reached from your code. Like, why would you even bother? And so there's a lot of, let's say, technology behind figuring out the reachability, not just on functional level, but also like data processing level. That is, say, this bug would only exhibit if you pass a null pointer to it, but you make sure that if the null pointer is never passed, in fact, you don't even have to worry about it. And so with the aid of AI, you can do all of these things in at scale and very reliably, which I think is amazing, and it really helps to operationalize the whole process.
So knowing more and being able to actually respond to what you know, it's an important piece. Can you give me, before we wrap, I want to have you share a story maybe from a client that experienced something really cool after working with you and the team at Isle.
Yeah, no. So we have clients across various verticals. We focus obviously on companies that produce a lot of code. It spans from financial services and software companies, but also to companies like Bose, for example, is a client of ours. So obviously known for their hardware and for their sort of firmware in that area. So we take care of the embedded piece. So we are very good at sort of uncovering vulnerabilities even in embedded code. The other example I would give is Ethereum, which is a very different side of the spectrum, obviously blockchain related, smart contracts, etc., where it comes with very specific types of vulnerabilities, types of bugs that exist that can be very existential, because obviously these technologies are touching money flows and must be very secure. So even though these code bases are super well audited and sometimes even like formally verified, there is a lot of accompanying code or even those core pieces that deserve additional checks, and so we help Ethereum Foundation, for example, in this regard to secure their code base.
Very cool, very cool. And I see a lot of names scrolling across the bottom of your website there. So a lot of examples, and perhaps we'll have a chance to share some more of those stories with folks. You're heading to Vegas, so maybe folks can connect with you in Vegas. If
Absolutely.
They're not going there for Black Hat and DEF CON, that is, of course, Isle.com, AISLE.com, and you'll learn more about all that the team at Isle is working on. And I would encourage everybody to connect with Ondrej on LinkedIn as well. Ondrej, thanks so much for sharing the story with us.
Thank you so much.
And thanks everybody for connecting on this brand story. Stay tuned for more.